Hello, welcome all to another Your Study Buddy. Today we are going to start with a topic called vectors in 12th class question bank series. So let us understand few basic before we proceed. Vector quantity. A quantity which needs to be described using both magnitude and direction is called vector quantity. For example, displacement, velocity, and you see a figure on the screen that shows the vector AB. It has a direction. It shows the initial point and the terminal point. So AB vector is moving in a specific direction with the given magnitude. Magnitude of a vector. Magnitude or size or a length of AB is defined as a length of segment AB. That is, magnitude of AB is length of AB. Triangle law of addition of two vectors. So if AB are the two vectors, consider a triangle ABC. So if each side is denoted by a position vector ABC, then small vector A plus B is given as C vector, that is AB plus BC is equal to AC. That is what is the triangle law of addition. Let A and B be vectors and Mn are the scalars. If C is equal to Ma plus Nb, then it is called a linear combination of AB, and then three vectors A, B, C are said to be coplanar. Coordinate of points on coordinate axis. As you can see on the diagram, it is a plane that is shown where you have three axes x, y, z. If I want to denote any point on two dimension, that is x, y, y, z or z x axis, when we want to denote the coordinate, it will be point A will be represented by x 0, 0, B as 0, y 0 and C is 0, 0, z. But at the same time, if we are referring to the three dimension or we are talking about the planes, xy plane, yz plane, zx plane, then when we are going to denote the coordinate, it will be lxy0, m0yz, and x0z respectively. An exam will be asked to write what are the coordinates in the xy or yz plane. So accordingly, you can write the answer. Show that the vectors 4i plus 13j minus 18k, I minus 2j plus 3k and 2i plus 3j minus 4k are coplanar. Let us simplify this problem. You have to show that the vectors A, B, C are coplanar. So if you can show that the one vector is scalar multiple of other two, we can prove that these three vectors are coplanar. So let us consider A is equal to NB plus NC. And let us substitute the values given in the problem. So A vector is 4i plus 13j minus 18k is equal to m into I minus 2j plus 3k plus n into 2i plus 3j minus 4k. So gathering the coefficient for I, j, k, what I am getting on the left hand side is, it is m plus 2n into I plus minus 2m plus 3n into j plus 3m minus 4n into k, and on the left hand side we have 4i plus 13j minus 18k. Now by the equality of two vectors, we can equate the coefficient of I, j, k, and we will be getting m plus 2n is equal to 4 minus 2m plus 3n is equal to 13 and 3m minus 4n is equal to minus 3k. So if I simplify these two first equations simultaneously, and if I multiply the first factor by 2, I am getting 2m plus 4n is equal to 8, and in second as it is. So what I will be getting here is 7n is equal to 21, n is equal to 21 by 7, that is equal to 3. And if I simply substitute this in equation 1, so m plus 2 into 3 is equal to 4. So m is equal to 4 minus 6 is equal to minus 2. So these are the values for n and m, and now we can express the vector A as linear combination of scalar combination of other two. So m being 4 into B vector minus 2, n is minus 2 into C vector. So as we can express as a linear combination, we can say that these three vectors A, B, C are coplanar. If three points A, B, C are collinear, find the ratio in which C divides the line segment AB and the values of P and Q. Let us solve the next problem. You have been given three collinear points A, B, C. And then you have been asked to find out the ratio with which one point is dividing the other two. And hence you have to find the values of P and Q. So let us assume that A, B, C, small a, b, c are the position vector for the points capital A, B, C. So what I can get A vector as 3i plus 2j plus pk. B vector, it is equal to qi plus 8j minus 10k, and C vector is equal to minus 2i minus 3j plus k. So by section formula, like we have been given this ABC, these points are collinear. So if we assume C is between A and B, we need to figure out what is the ratio in which it is dividing the line segment AB. So let me assume that C is dividing. So let us write, let C divides segment AB in the ratio T as to 1. This is what we are assuming. And we will find out the value of T so that we will be knowing what is the ratio in which the C is dividing the line segment AB. So by section formula, what I get? So by section formula, we get what we get? We get C vector is equal to, it is T into B vector plus 1 into A vector upon T plus 1. That is what is the formula for the section formula when one point is dividing the segment in the ratio T as to 1. So let us substitute the values of the vectors from the problem given to you. So minus 2y minus 3j plus 8 is equal to T into. So B vector is qi plus 8j minus 10k plus 1 into A vector is 3i plus 2j plus pk whole upon T plus 1. So let us cross multiply. So what are we getting? T plus 1. So minus 2i minus 3j plus k into T plus 1, it is equal to, so let me gather the coefficient for I, j, k from the right hand side. So what is getting? Q into T plus 3 into I plus 8 into T plus 2 into j plus 10, it is minus 10 into T plus p into k. And on the right hand side, if I just want to expand this, it will be minus 2 into T plus 1 into I minus 3 into T plus 1 into j plus T plus 1 into k. It is equal to the same term that we have written on the right hand side. Into T plus 1, it is equal to, what is the coefficient of I on the right hand side? Is TQ plus 3. Similarly, for j we are having minus 3 into T plus 1 is equal to, it is 8T plus 2. And lastly, we have T plus 1, it is equal to minus 10T plus T. Now let us simplify and let us see what is the value of T. So if I simplify the third one, I will be getting 11T is equal to P minus 1. Right? So if I transfer this here, it will be minus 11T is equal to 5. So T is equal to minus 5 by 11. So we have the value of T with us. Let us find out what is the value of T. So it will be 11 into minus 5 by 11 is equal to P minus 1. So what I am getting is minus 5 is equal to P minus 1. So minus 4 is P. So P is minus 4. Now we need to find out the value of Q here. So let us simplify the first equation now to get the value of Q. So we get minus 2T minus 2 is equal to TQ plus 3. That means if I take T common here, so it will be minus 2T minus TQ is equal to 5. Or if I take T outside, I get minus T outside, I get 2 plus Q equal to 5. Now let us substitute the value of T that we have obtained here. So it is minus of minus 5 by 11, 2 plus Q is equal to 5. So 5 we can omit from both the side. 11 we can transfer here. So it is 2 plus Q equals to 11. Q is equal to 9. So the required ratio will be, it is 5 by T is the ratio. So it is 5 by 11 minus 5 by 11, right? So this minus sign indicates it is externally C is dividing A and B, and the ratio is 5 as to 11. So 5 as to 11 is the ratio, and it is the external division, and these are the values of P and Q. a line passes through the point 6, minus 7, minus 1 and 2, minus 3, 1. Find the direction ratios and the direction cosines of the line so that the angle alpha is acute. Let's solve the next problem. You have been given that the line passes through the point 6, minus 7, 1 and 2, minus 3, 1. You have to find out what are the direction ratios and direction cosines. So these are the 2 points through which the line is passing. We need to work out what are the direction ratios. So first of all, let me assume A vector, your position vector for point A, so it will be 6i minus 7j minus k, and B is the position vector for point B, so it will be 2i minus 3j plus k. Okay, always put the hat, dash on the hat. And here, when we find out what is the value of AB, so AB vector is B minus A, giving you 2 minus 6, that is minus 4i, minus 3 plus 7, that is plus 4j, minus 1, giving you minus 1, minus of minus 1, that is plus 2. So it is 2k. So these are what are the direction ratios. So I can write down this is the vector AB. So therefore direction ratios for AB, vector AB will be minus 4, 4 and 2 respectively. Now for finding out the direction cosines of AB, let us assume that the direction cosines be minus 4k, 4k and 2k. We do not know what is the value of k, we will figure out that. So the property of direction cosines, what we know, L square plus m square plus n square equal to 1. So using this property, what will be getting? Minus 4k square plus 4k square plus 2k square is equal to 1. So it is 16k square plus 16k square plus 4k square equal to 1. 32 plus 4, that is 16 into k square equals to 1. K square is equal to 1 by 36. K is equal to plus minus 1 by 6. So now we want to figure out the value of k such that here the angle form is acute. In the given problem, it is given that it is a line passing through these 2 points so that angle alpha is acute. This is what is given in the problem. So using that property, the angle alpha will be acute if cos alpha is greater than 0. That means k should be less than 0, isn't it? Because we already have a negative sign here. So if k is negative, then only it will be minus into minus, it will be plus and it will be greater than 0. So for that only reason, k will be taking the value minus 1 by 6 and not plus 1 by 6. So now as we have the value of k, we can work out the remaining direction ratios. It will be minus 4 into minus 1 by 6, 4 into minus 1 by 6, 2 into minus 1 by 6. Therefore, direction cosines are, it is 4 by 6, that is equal to 2 by 3. It will be minus 2 by 3 and lastly it is equal to minus 1 by 3. So this is how we are going to work out the direction ratios and direction cosines for the given problem. So this is how we are going to solve the problems on vector. I hope these problems are very much clear to you. So if you find this video helpful, do like, comment and share and click on the bell icon. Stay tuned for the next upcoming part 2 for the vector series. So see you very soon.